All right, welcome back. Today we are on day 4 of Unit 7, ACT Prep Trigonometry, and today we're going to talk about the graphs of trigonometric functions. So the first two we're going to talk about are sine and cosine. Trigonometric functions repeat themselves, so the period of a trigonometric function is the distance required to show one full cycle. You should be able to recognize the graphs of trigonometric functions. Those shown below are for one period of each function. So when we look at the sine function, the way it's easy to recognize the sine function is sine always passes through the origin, whereas cosine passes through the amplitude. Okay? So for sine, the generic equation for sine is a sine times bx, or sine of b times x. Okay? That a, for the mother function of all sines, a is 1 and b is 1, which means your amplitude, this is your amplitude. So see how the sine only goes as high as 1 and as low as -1. The sine function oscillates between +1 and -1 unless you change that value of a. If this was a 2, then your amplitude would be 2 and it would go up as high as 2 and as low as -2 and come back up. And if you change the value of b, this distance changes. When b is 1, then sine will finish one complete cycle in a distance of 2 pi radius. Okay? So if you change the value of this, that might either make it take a lot longer to finish a cycle, or it can shorten its cycle and make it finish quicker. Okay, and that's what changing the value of b does. For your cosine function, again, the generic would be a times cosine of bx. Mother cosine is a is 1, which means it has an amplitude of 1. It goes as high as 1. It oscillates between 1 and -1. And mother cosine has a b value of 1, which again means that for sine and cosine both, the period for sine and cosine is 2 pi. Unless you mess with this b, okay, sine will finish a complete cycle. There's a one complete period of sine, and it will finish by 2 pi. For cosine, the only difference is the cosine doesn't start at 0. The cosine starts at its amplitude instead. And then it comes down to the 0, and then to its down amplitude, and then back to 0, and then back to its up amplitude. And that's what one complete period of cosine looks like. Okay? And again, if I change this, then the height of the dips or the peaks will change. And if I change this, that will either lengthen or shorten the distance that it takes to finish one complete cycle of cosine. Okay, then we have cosecant and secant. If you remember right, cosecant is reciprocal to sine. Well, what's interesting is if I graph the sine function, it would do this. And so what you got to remember is since cosecant is reciprocal to sine, all you do is kind of sketch the sine function, and then what you do is you put your little half parabola or parabolas where at the amplitude, I guess, up here and here. Okay? Your secant is reciprocal to cosine. So if you remember cosine, see how this is shifted over to pi over 2? So this would be the 0, okay? So cosine would have started up here at 1, and it would have come down and down to 1. Oh, wait a minute. Secant is reciprocal to cosine. Oh, okay, they're splitting this into, well, they've only given me half of a, well, the graph isn't big enough, but basically, the same thing is going to happen on cosine. You put these parabolas at the peaks and at the valleys of the cosine function. Okay, the other thing I wanted to talk to you about, I guess I should have talked about sines, okay? If a is positive, then you would start at 0, go to your positive amplitude, then back to 0, then down to your negative amplitude, and then back to 0. If A was negative, you would actually, it would go, let me change colors. It would go reversed. If A was negative, you would go down to its amplitude, then to 0, then up to its amplitude and back to 0. So this is what sine would look like if A was negative, okay? Same with cosine. If you were doing cosine and A was negative, you would start at its down amplitude and then come to the 0, and then up amplitude, come to the 0, and then down amplitude. So a negative value of A would make cosine upside down. Okay, same with these guys. All right, if cosecant is negative, then that's going to flip this one down and this one up. If secant was negative, again, that's going to flip this one down and this one up. Okay, so watch your signs. They like to do that to you. All right, your tangent and your cotangent graphs. Tangent always passes through the origin, and it waves from bottom to top towards the right. Your cotangent doesn't pass through the origin, it passes through pi over 2. It's shifted over here. So cotangent actually would look like this. Okay, so it's shifted over pi over 2 units, and then it waves from the top to the bottom towards the right. Okay. Tangent and back up, I'm so sorry. Cosecant and secant have, well, they kind of have an amplitude, but the amplitude is not defined. And it's because this goes forever and ever up, and these go forever and ever down. So you don't really get to a highest or lowest point. Okay, so amplitude is not defined for cosecant or secant. Same with tangent and cotangent. There is no amplitude, because there's not a highest point amplitude. There's no, the amplitude for tangent and cotangent isn't defined either for there. Okay, let me back up again. Sorry, I keep thinking about different things to tell you. To figure out your period, okay, like I said, sine and cosine will finish a period in the distance of 2 pi radians. If you've messed with B, that will change it. So your formula to figure out the period for sine and cosine is it's 2 pi, that's mother, divided by B, whatever this is, will give you your new period. Same with cosine. Your period would be 2 pi over whatever this is, and that'll tell you the distance that you have to finish a cycle. Okay, same for cosecant and secant. The period for both of them is going to be 2 pi divided by B. B would be whatever's touching X. Okay? For tangent and cotangent, your period is a little different. Your period is just pi, because period for tangent and cotangent, they finish a cycle by pi. So to get the period for tangent and cotangent, it's not 2 pi over B, it's just pi over B. Okay, and again, B would be whatever touches X. Okay, so they're talking about, now they're showing you how, if I see how I change this amplitude number. So here's mother sine, who has an amplitude of positive, or of 1. It oscillates between positive and negative 1. When I change this to 2, it's going to stretch it. So it's going to go up to the 2 and down to the negative 2 before finishing a cycle. You cannot see how now here they say y equals sine of 2x. Well, what that means is normally the period for sine is 2 pi. But when you mess with this, the period gets changed. So now the period for this function would be by pi. So here's mother. Sorry. Here's mother. Y equals sine x. Okay, and then if you look at sine 2x, see how it finishes one of its cycles by pi, which is what it came out to be. And again, it shrunk it. Okay. Okay, so that's altering your length of your period. So go ahead, give this one a shot. Come back when you're ready. And hopefully you got pi over 2. Here's your equation. For tangent, your period is pi over b. So my period is going to be pi over, my b is 2, it's going to be pi over 2. Okay? Try this one, hit pause, come back when you're ready. And hopefully you got F. Okay, it's because they haven't messed with the period, this cycle has to finish by 2 pi. Okay, so that one does. See how this one finishes by pi, so that's got the wrong period. This one finishes at 4 pi for one cycle, so that's the wrong period. This one is the right period, it finishes by 2 pi. So now I'm into these three. Well, it can't be this one because sine passes through the origin unless you like added 5 out here on the end, or for this one you'd have to add 2 on the end to shift it up 2 units, but that would be addition on the end, not multiplication in the front, so that's not right. So now it's between these two. Well, look at my amplitude. This graph has an amplitude of 2 because it goes as high as 2 and as low as negative 2. This only goes to 1, so it's not this one, that's got the wrong amp. This one's bad because it's shifted up, so it's got to be X. Okay? Try this one. Oh, no, I guess we're practicing again. Okay. So given below is one full period of the graph of a trigonometric function. 1. What is the amplitude of the graph? Well, it goes as low as negative 2. Your amplitude is the absolute value of A, so the absolute value of negative 2 would give me an amplitude of 2. The period of the graph, well, this is one full cycle of cosine, and it's finished by 4p, so my period is equal to 4 pi. Okay, and then they want the equation of the graph. Well, to get the equation of the graph, you have to have A and you have to have B. Well, I know A is 2. Okay, to get B, you just said that the period was 4 pi. Well, we know that the equation for period for cosine is 2 pi over b. So, if I solve this proportion here, I have 4 pi times b equals 2 pi. I'm trying to get b alone, so divide by 4 pi, and I get b equals 1/2. So my equation, there's a, there's b, my generic equation for cosine is a cosine bx. So I put a there, b there, and my equation is y equals 2 cosine of 1/2 x. Okay? Alright, for 4 through 6, it wants me to use this equation. So keep in mind, a is 1/2 and b is 1. So it says, what is the amplitude of the graph of this equation? Well, this is a cosecant function, so there is no amplitude. It's not defined. The period of the graph, well, period for cosecant is 2 pi over b. Well, my b is 1, so my period is going to be 2 pi over 1, which is 2 pi. Then it wants me to draw a graph of one period of this function. So what I do is I draw my little graph here. Okay, and then I know that if my period is going to be 2 pi, alright, I'm going to go over here to 2 pi, and then what you do is you always cut this into fourths for sine and cosine, or cosecant and secant. So I'm going to do 1, 2, 3, 4. And then what you do is you cut this 2 pi into fourths. So this would be 2 pi over 4, which would just be pi over 2, but sometimes it's easier for people to go, you take the end and cut it into fourths, so it's 2 pi over 4, right? And then, so that reduces down to pi over 2, so I'm counting by pi over 2's, which would make this 2 pi over 2, and it would make this 3 pi over 2. Okay? And yes, this would be the same as pi, but like I said, I kind of like to see it. So what I like to do is I like to, the reciprocal to this, or would be the sine function, okay, because cosecant is reciprocal to sine. So if I was graphing the sine function, let's call this 1/2 and 1, and negative 1/2 and 1. If I was graphing sine here, what you would do is you start at 0, this is positive, so I'm going to go to my up amplitude, and then my next mark would be 0. My next mark would be down amplitude, and then 0. And I'm just going to sketch that. And what that helps me do then is I can see, since I know that the parabolas will be at the peaks of the curves, okay, I know that at the zeros I have asymptotes. And then what you do is the parabolas are going to be asymptotic to the axis and the asymptotes. So this curve is going to do this, and this curve is going to do this. And that would be one period of cosecant. Okay? Okay, given below is one full period of the graph of a trigonometric function. I recognize this as sine because it's passing through the origin, and it comes up to its amplitude, back to 0, down to its amplitude, back to 0. Well, the amplitude, it oscillates between 3 and -3, so my amplitude is 3. A equals 3. The period, it finished at 2 pi, and then they want the equation of this graph. Well, your equation for generic sine is A sine bx. Alright, I got my A. I know A is 3, so that's going to go there. Period for sine is 2 pi over b. My b is, well, and I know that my period was finished in 2 pi. I can see by the graph. So if I solve this little proportion here, I got 2 pi equals b times 2 pi. To get b alone, divide by 2 pi, and b has to be 1. So I put 3 here and 1 here, which makes my equation y equals 3 sine x. Okay? Alright, it says draw a graph of one period of the function y equals negative cosine 2x. Okay, so we've got a equals -1, and I've got my period is equal to 2 pi over b. So in this case, it's going to be 2 pi over 2, which comes out to pi. So this is going to be shrunk down, and it's going to flip over. So, if I draw my little graph, I've got to finish one cycle by pi now, not by 2 pi. So you mark pi, cut it in fourths. So this would be pi over 4, which is what I'm counting by then. So this mark would be 2 pi over 4, and this would be 3 pi over 4. Okay, so you break your graph up. And then for cosine, you start at the amplitude. But because this is negative, I start at -1. So my first mark is going to be at -1, then to the 0, then to my up amp, and then to my 0, and then back to my down amp. So this one period would look like that. Okay? Alright, hit pause, come back when you're ready. And hopefully you got C. So they want me to find the following as a graph of this function. Well, I know that the amplitude is 1/2, so that's the first thing I'm going to check. That's got the right amplitude, wrong amplitude, wrong amplitude, wrong amplitude, wrong amplitude. Gee, that was easy. I didn't even have to check the period. Okay? And the only one that had the right amplitude was C. All the rest of them had the wrong amplitude. But if you did check the period for sine is 2 pi over b. So my 2 pi over b would be 2 pi over 2, which says I have to finish a cycle by pi. And this one finished by pi. This has the wrong period, wrong period, wrong period. This one does have the right period, but the wrong amplitude. Okay? Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got H. So it says, what is the product? So it's telling me to multiply the amplitude and the period together. Well, my amplitude is 3. Period for cosine is 2 pi over b. B is 2, so my period is 2 pi over 2, which gives me a period of pi. And if I multiply those two together, I get 3 pi. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got B. So it says, what is the period of the graph of the equation y equals -2 cotangent pi x? They're telling me that A is -2, even though we don't have an amplitude, and B is pi. Well, for cotangent, your period is pi over B. So if there's my B, and period for cotangent is pi over B, I put pi over pi, which gives me a period of 1. Okay? Go. Hit pause. Come back when you're ready. And there you go. Okay, you could approach this a couple of ways. You could figure out everything on your own and then match to the graph, or you could try and do a process of elimination. I look at elimination and I know this is a sine function, so I can get rid of cosines. I know that the amplitude is oscillating between positive and negative 0.5, so the amplitude has to be 1/2. And it actually has to be negative 1/2 because sine went down first instead of up. So it's got to be a negative 1/2. Well, that puts that out, and that's the only thing possible. The other thing you could do is check the period. Period for sine is 2 pi over b. Well, this finished at pi over 2, so this would make 4 pi equals b pi. Divide by b, I mean pi, and b has to equal 4. Okay, so you could have checked a couple of things to answer that. Alright, try this one. Hit pause. Come back when you're ready. And hopefully, come on. Alright, where'd it go? Oh, there's E. Sorry, I was looking for the green arrow. Check mark. Okay, so they want to know which of the following is the graph of one period of y equals tangent of 2x. Okay, first of all, tangent, unless you reflect it with a negative, tangent has to go up to the right. Okay, so that would be a cotangent, and that would be a cotangent, and that would be a cotangent. Okay, so it's between A and E. Well, that must mean my period. This is pi over 4, this is pi over 2. Well, period of tangent is pi over B. B is 2, so I have to finish a cycle by pi over 2, not tricky little buggers, aren't they? Okay, I forgot to tell you. One full cycle of tangent, okay, this keeps on going. So this would be to pi, and this happens again then. And it comes up like this, through here, and up like this, and it ends by pi. So if you're going from a full cycle of tangent, okay, if you're starting at 0, it's this piece and then this piece makes one complete cycle. So if it's kind of weird. People think that this is the complete cycle of it. It is, but see how you're not starting at 0, you're starting over here. So if you have to be done by pi over 2, well, that would make, here's your pi over 2, which would have this part of it. And that would end at pi, one complete cycle, because you have this part, not the bottom. You just have this part, and this part is one complete cycle. So be careful. Tangent is a little tricky. Okay. So that does it for our graphs of trigonometric functions. And I will see you next time.